Hello everyone, today we are going to do 4.5, which is linear dependent and independence. Okay, so let's take a look at the goal for this section. Why we want to do this? Firstly, let's review what we did in the last section, which is called the spanning set, right? So for example, let's see. We have like 1, 0, 0, 1. Okay, this can span which one? This spanning set for R2 because any vector in R2 can be expressed by those two vectors, right? And also we can see 1, 0, 1, 1 also spans R2, and also there's another spanning set 1, 0, 0, 1, and 1, 2 that they are all spanning set for R2 actually. Okay, but the first two has only 2 vectors, but the third set has 3 vectors. So our goal for this section, we want to find the easiest or the spanning set has the smallest number of vectors. So let's see, we want to minimal the spanning set. Okay, so let's see. For example, for R3, we want to have only 3 vectors. The numbers can be different, like in each vector, the number can be different vector, but it has 3 vectors. We don't want to have 4 vectors because that's not the easiest spanning set. Okay, so this is our goal for this section. Now let's take a look at the definition. What is dependent and independent? Okay, so let's see definition 1. Firstly, we have a finite non-empty set has k vectors. Let's take a look. A finite non-empty set of vectors. So those vectors we write down v1, v2, and vk. We have k vectors here in a space, vector space. Then this set is said to be linear independent. So let's take a look. v1, v2, this set vk, they are all vectors, is said to be linearly. Linearly means there's no power, just a linear combination. Okay, dependent. If there exist scalars, so scalars c1 to ck, they are like the combination. Do you still remember the linear combination c1 v1? Okay, they are not all zeros. Such that in the future we just write down s dot d dot the linear combination c1 v1 c2 v2 plus ck vk equals 0. Okay, so it's pretty difficult to understand from here, right? The definition linear dependent means there exists a non-zero ck some coefficient, okay, not all zeros. So just remember those keywords. Linear dependent means not all zeros to make this linear combination. I'm going to give you an easy example and let you to understand what's the meaning of dependent. Dependent means, for example, if we have 3 vectors, so we don't do k, we can just use v1, v2, v3, okay? And we have a linear combination, for example, and c3, v3, make this equal 0. We have this linear combination. If the c1, c2, c3 are not all 0, so there are at least one non-zero C, right? So if we choose C2, it's not 0. Or it may be C1, but we don't know. Suppose at least 1. So we suppose the non-zero is C2. So we can, solve for CV2. So let's see. C2V2 equals negative C1V1. Move C1V1 and C3V3 to the other side. And because C2 is non-zero, so we can divide by C2 V3. So you can see that means CV2, the vector, can be expressed by the other two vectors. So in this case, we say they have some relationship. V2 depends on V1, V3. Okay, so they are called linear dependent. So for the linear dependent, there must be a non-zero coefficient C1, Ci, or Ck. Okay, non-zero coefficient C. Can you understand what the meaning? If we have non-zero, so we can find a linear combination for one vector, so they have some relationship. That means because this vector can be expressed by the others, so this is depend. They depend on each other. Okay, so this is the definition for dependent. Definition 2. Independence. Vk is said to be, this set is said to be independent. Independent means they have no relationship, and similar to the first definition, if it's opposite to the first definition, so all the C have to be all zeros. For dependent, there's non-zero C, but for independent, all the C have to be 0. If the only value of C1 to Ck, for which the linear combination, same thing, C1V1 plus CnVn equals 0, and all the values are C2. They have to be all zeros. Okay, all 0. Let's see. Independent, keep in mind, independent means all the C equals 0. Okay, independent, all the C equals 0. Dependent means non-zero C. And the meaning means independent means no relationship. Dependent means they have some relationship. Now let's take a look at just some properties. The first one is given by theorem 1. So let's see. There are two properties here. Any set, the first one, any set of two vectors. So this set only has two vectors. If the two vectors are proportional, okay, then this is dependent set. So any set of two vectors in V is linearly dependent. I will give you some examples later. Okay, if and only if the vectors are proportional. This is the first property. And the second one, any set of vectors in V containing the 0 vector is dependent. Okay, so let's see. Any set containing the 0 vector is same thing, dependent. Let's take a look at the example 1. The first one means proportional, right? So here, let's take a look at, we have two vectors. V1 is 1, 2, negative 9, okay? And then we have two vectors. The other one is v2. So proportional, we can choose this to be like negative 2, negative 4. Proportional is like we can use negative 2 times v1. The other one is given by this one, and 18. So we can see they are proportional, right? So for example, 1, 2 and the vector 2, 4, they are proportional. And also 3, 6, they are all proportional, right? Those vectors. And here v1, v2 are proportional. We noticed this. And we noticed actually v2 equals what? v2 equals negative 2 v1, right? Because they're proportional, it's like a v2 equals k v1. And then if we move them to one side, so it become 2 v1 plus v2 equals 0. So you can see this is the linear combination. In the definition, it's like c1 v1 plus ck vk. But here we only have two vectors, right? And do we have non-zero c? Yes, both c are non-zero. Okay, so we can say v1, v2, they are dependent. Okay, all this set is dependent. Vectors are dependent, all the set is dependent. Same thing. Let's see. Let's example satisfy the first property in the theorem 1. Any set of two vectors if linear dependent if and only if the vectors are proportional. Okay, this is the example for the proportional vectors. The second one, let's take a look. The second one, the vectors are matrices. Let's see, they are all 2 by 2 matrices. This is A1, A2, 0, 0, 0. The set include a 0 vector, and the vector is just a 0 matrix. Okay, we have 3 vectors here, and we want to test if A1, A2, A3 is dependent or independent. Actually, you can see this is dependent because, let's see, we can do 0 times A1. And because the second vector is 0 vector, you can do any number. You can do any number. This can be any non-zero number. And plus 0 times A3. And still can give us 0 vector. Right? So it's like C1V1 plus C2V2 equals 0. Same thing. And there exists one non-zero number. So C2 can be non-zero. In this case, we can see by definition, we know A1, A2, A3 are dependent. Okay. Now let's take a look at the second example. So we are going to do several examples here, and after we do more and more, we will remember and understand what is dependent and independent. Let's see, we have 3 vectors. Here, if we have V1, 1, 2, negative 1, V2, which is 2, negative 1, and 1, and the V3 vector, which is 8, 1, 1. We want to show that this is the set of V1, V2, V3 is a dependent set. Is dependent in R3. And we want to determine the linear dependency relationship. The linear. Let's take a look at how to do this example. Okay, so firstly, we want to show they are dependent. So we want to use the definition, which means C1, V1 plus C2V2 plus C3V3 equals 0. And if we can show C1, C2, C3 are not all zeros, so that means, okay, let's write down more. So we want to show what C1, C2, C3 are not all zeros. That means what? Okay, let's see. C1, we plug in V1, 1, 2, negative 1, plus C2, 2, negative 1, 1, plus C3, V3. This is just by definition, linear combination, and this should be equals 0 vector. That means 0, 0, 0. Okay, and we simplify the left side. The left side means we can just combine all the vectors on the left side, right? Combine those vectors, and it can give us 3 equations, like 3 component. The first component equals 0, second component, and the third component each equals 0. So let's see what's the first component if we combine those 3 vectors, linear combination on the left side. So it should be C1 plus 2C2 plus 8C3. Is that correct? That's the first equation. And the second equation, you can see that's the second component, 2C1 minus C2 plus C3, right? And the last one, negative C1 plus C2 plus C3 equals 0. So you can see this is a linear system with 3 unknowns. So this is linear system with C1, C2, C3 as unknowns. We can solve this linear system, right? And if we have non-zero solution, that means all the C's are not all zero, then we can say this set is dependent. So that's our goal. So we want to test whether there exists non-zero solution. If all the solutions are zero, independent. If non-zero solution, dependent. Okay, so let's solve this. Do you still remember how to solve the linear system? Let's have a quick review. We do augmenting the matrix, right? And the augmented matrix include all the B's. So 1, 2, 8, 2, negative 1, 1. 91, 1, 1. Let's take a look at this one. So now we want to reduce this into row echelon. Okay, so let's try. So 1, 2, 8, 0. Let's skip the detailed calculation. Okay, because the calculation is pretty, we need several steps here. Let's just skip the detail. But I suppose everyone knows how to do elementary row operations. Okay, do row echelon because we want to solve it, right? And the row echelon form for this one is this one. 0, 1, 3, 0, 0, 0, 0, 0. Do you remember in this case? In this case, we have unique solution, or infinite solution, or no solution. Do you know which case this one has? Actually, this has infinity solution because x1, x2, they both has leading one. So let's have a review. x3 need to be free variable, right? So this is x1, x2, x3, we make that to be the free variable. So let's see, x3 equals t, and from the second row, x2 equals negative 3, because look at second row, it's like x2 plus 3t equals 0, move to the other side, negative 3t, right? And x1 equals negative 2t. So what's the solution? Solution set is, here is t, negative 3t, sorry, I need to write down the order x1, x2, x3. So it should be negative 2t, x2 negative 3t, and the t is the solution set for C1, C2, C3, right? So we can see t can be anything. Definitely, there's non-zero solution for C. Because we have infinity solutions, definitely all the solutions are not zero. So we can just say V1, V2, V3 is dependent. Oh, you can say there exists a non-zero solution, then this set is dependent. Okay, we can try this exercise problem. 1, 2, 3, 1, negative 1, 2, 1, negative 4, 1. Test this set is dependent or independent. Here is the solution, but you can try by yourself. Firstly, I set up the linear combination, so that means I set up C1, V1, plus C2, V2, plus C3, V3, equals 0, 0, 0, 0 vector. Okay. Then I get three equations with three unknowns of C1, C2, C3. So the first one, C1, C2, C3 equals 0. The second one is 2C1 minus C2. The third one should be, look at the third component, 3C1, 2C2, C3 equals 0. And then I write down, I want to solve for C1, C2, C3. I write down my augmented matrix, which is 1, 1, 1, 0, 2, negative 1, negative 4, 0, 3, 2, 1, 0. Reduce this into row echelon, so it should be 1, 1, 1, 0. And the first step, I reduce those into zeros. So 0, negative 3, negative 6. Times negative 3 are there, negative 1 times negative 3, negative 2, 0. And the next reduce, let's see, the second row we can divide by negative 3, right? If we want to get 1 there. So 1, 2, 0, 0, negative 1, negative 2, 0. And here 1, 1, 1, 0, 2, 0. And the last row, you can see, because they are proportional, we get a 0 row. In this case, there are infinity solutions for C1, C2. So if you don't want to find the solution, if it's just asks you to tell it's dependent or independent, don't ask you to find the relationship, then you can just say there are infinity solutions for C1, C2, C3. So you can see, you can just say V1, V2, V3 is dependent set. Okay, so just like this. This is the example 2. Let's see, next we're going to do more example. Next, we just play with the definition. Example 3, determine whether the three given matrices are dependent or independent. So, determine whether. So we have 2 by 2 matrices. They are 1, negative 1, 2, 0, A2, A3 are dependent or independent. Okay, so let's see. Same thing by definition. What's the definition? C1, V1. So here I just plug in A directly, okay? But the vectors, they are just matrices. That's okay, same thing. And the C2, V2, C3, V3 equals 0 vector, but 0 vector in matrices should be 0 matrix, 0, 0, 0, 0, right? And now let's set up the equation, and because here we have four elements, so we can set up 4 equations. Let's write down the first equation. First equation means for the A11 position, that means C1 plus 2C2. You can combine the left side, in the other step, but usually I just look from here. I just look at my A11 position, what is the sum? Plus C3 and equals 0. The first equation, right? And you can try to write down the other story. The second one, we can say A12 position. So negative C1 plus C2 minus C3 equals 0. And then we get 2C1 plus 2C3 equals 0. And the last equation is the last element, A22 position. So it should be 0 plus 3C2, right? 3C2 plus C3 equals 0. So we have 4 equations, 3 unknowns, but it's okay, no matter how many, what's the system look like, we'll just write down the augmented matrix. 1, 2, 1, 0, negative 1, 1, negative 1, 0. And the third row should be 2. Be careful, 0, 2, 0, because there's no C2, right? And there's no C1. And 3, 1, 0. Reduce this into row echelon. So, same thing here. I skip, the detail, but this one, the numbers are pretty small, should be easy to reduce into row echelon. But to save some time, this becomes, second row becomes 0, 1, 0, 0. After we reduce this one, we get this. Okay, so we need to know here, let's see. Even we have 0 row, but be careful, we only have 3 unknowns, right? So let's see who has leading 1. X1 has leading 1, X2 has leading 1, X3 also has leading 1. So there is no free variable, even there's a 0 row. So it's different from before, right? Because we have additional one more equation here. So actually X3 equals what? From the third row, you can see X3 equals 0. From second row, X2 equals 0. From the first row, because X1, X2, they are both, X2, X3 both at 0, X1 is also 0. So in this case, I shouldn't say X1, I should say C1, C2, C3, because our unknowns are C3, C2, C1. So all the C's are 0 in this case. All the coefficients are 0. What's the conclusion we can get? They are independent, right? So we can say A1, A2, A3 are independent because all the C's are 0. Here's the exercise problem for our example. So we want to tell if A1, A2 are dependent or independent. Let's see. We write down like this way. I'm going to write down C1, C2. We only have 2 matrices, right? But it's okay, so it should be easy. This problem, the first component, first equation, 2C1, A12 position, negative C1 plus 2C2 equals 0, A21 position, 3C1 plus C2 equals 0, and 4C1 plus 3C2 equals 0. And then we solve this linear system. When we solve it, write down augmented matrix. And reduce this into row echelon. Okay, I'm going to make the second row into the first row because I need the leading one, and I change all the other numbers into 0. So here negative 1 times 2, and switch first row into the second row. So 0, this times 2 should be 4 minus 3, 0. Okay, and This times 3, add row 3, 0, times 3, 7, 0, and here is times 4, 0, and 2 times 4 should be 8. 8 plus 3, 11. But it's okay. They will be like, we can change them all into 1 ones, right? So like 1, negative 2, 0. After we simplify, we get what? 0, 1, 0. Because they are all proportional, we get 2 0 rows. But it's okay. Even we have 2 0 rows, here we only have x1, x2, c1, c2. So we get c2 from second row. We know c2 is 0. Okay, and the c1 is also 0. In this case, c1, c2 are both 0. We say c1, so we say a1, a2 are independent, or we say the set is independent. Same thing. So a1, a2 are independent. No relationship, okay, because all the coefficients equal 0.